Hello, I welcome you all to this another interesting screencast, and the problem reads: handles, forces F1 and F2 are applied to the electric drill. Replace this force system by an equivalent resultant force and couple moment acting at point O. Express the results in Cartesian vector form. Vector form. This was form. This one is not from form. Form as in form. Okay, like that. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. So we can solve this particular problem either by using vector or scalar analysis. It's really up to you. So you choose which approach is okay for you. Alright. So I'll go for the vector analysis. So I'll need some moment vectors. Moment vector arms. Alright, so I have one there, and then let me say I have another one there. I need this, and I need to define them. So let's say this point here, let's name these points. As we name this point here as point 1, we name this point here as point 2. No, the other way around, sorry. We name this as point 2, we name this as point 1. I just want them to match with the forces. There's nothing wrong even the other way around. I just wanted them to match with F2, F2, point 2, F1, point 1. Alright. Right. And then let's write down the position vector, which are the moment arms, Oliver arms. So we know that R1, okay, is going to be equal to, what are the coordinates from point O as our reference? R1 is equal to the coordinate in the X. Do we have anything in the X? We do have. It is 0.15 I. Then in the Y, do we have anything in the Y? For 1, in the Y we don't. Then in the Z we do have, it is 0.3 K. Then R2, we're done with this one, right? So we said 0.15 in the X and 0.15 and 0.3 in the Z. Then 0.2 in the X we don't have, but in the Y we do have is negative 0.25 J, and then in the Z it is 0.3 K. Great. So we have this, and we have also the forces. Okay, F1 is given as 6I minus 3J. Alright, 6I minus 3J minus 10K. Okay, and then we do have another force there. This is going to be equal to 2J minus 4K. Alright, so let's start with the summation of forces. So say summation of vector forces is going to be equal to the resultant force, which is just going to be equal to F1 plus F2. Okay, and therefore the resultant is just going to be equal to, let's sum them up, 6i, okay, it's the only I, minus 3 plus 2, that is just minus 1j, okay, and then minus 10 minus 4, that is minus 14k, and the unit for this is just newtons. And then the moments, summation of, or the resultant summation of moments about point O is just going to be equal to the resultant couple moment, which is equal to R1, right, cross F1 plus R2 cross F2, right? Great. So let's write this, we feed it in our tools. These are tools, I normally call them tools to make our work easier. So we have I, we have J, we have K, we have I, we have J, we have K. What is R1? We already found what R1 is. It's 0.15. J is 0, and then 0.3. And what is our force? Our force is 6 minus 3 minus 10. The other side, R2 is 0 here, then minus 0.25, and then 0.3. The force is 0 here, then a 2, then a minus 4. Alright. Great. So there we go. So we have I. This is 10 minus the other one. This becomes 0.9, right? Then minus J. That's minus 10 times 0.15, and minus 6 times 0.3. Okay, so this is minus 3.3, and then plus K. K just minus 3 by 0.15. So this is just minus 0.45. Then plus, we go to the second one, I as minus 4 by minus 0.25, and then minus 2 by 0.3. Okay, so this is 0.4, then minus J is just all 0. Then plus K, it is also 0. Is it so? Therefore, our resultant couple moment is just going to be equal to, which is moment about point O, is equal to -0.9 plus 0.3. 0.9 plus 0.4. They are both positives, so this is 1.3 I. Then this is a plus. This is a plus 3.3 J, and then this one there, it is a minus 0.4 5K. Alright, so this is Newton meters. I think this is about it. So we have the resultant force. There we go. We have the resultant equivalent couple moment acting at point O. So this is about it, and I hope the video is helpful, and if it was, give me a thumbs up, like my video, continue subscribing, and ring the notification bell. Bye bye. See you in my next screencast.